So this is an example, example 3 of section 16.5, flux of 0, y, z squared outward through the surface of the, and this is a cylinder, and alongside the x-axis between the plane x equal to 0 and 1. So the bounds for x is between that. So let's try to parameterize it first. It looks like a circle. If I was going to parameterize circle, I would go y equal to, what is the radius? Let's see, radius here is 2. So I would go 2 cosine theta, z equal to 2 sine theta. But then z is the free variable, so I can do x equal to x is the free variable, so x equal to x. So g of x and theta ends up to be x 2 cosine theta 2 sine theta. Now I could basically find g sub x and g sub theta and multiply it together. Oh, let's go back and remember, we're trying to find a flux. What is flux? Flux is the surface integral f and dot ds. So what I need to do after parameterization, I have to either use this formula. There are two formulas I can use. So I can either use f of g dot n, and then basically compute the, let's write ds over s with the, this was the vector line integral, this is the scalar line integral. Or I can do this, basically replace that n by capital N over the magnitude n, and then don't write s in here, not over s, because the bounds change basically. And then what is ds? ds is dA times the, it's the surface element, so it's multiplies by n, and over the d of u and v, whatever u and v are. And so these two simplify together, and that's the other formula that I have, basically dot n dA. So I can use either of these formulas, right? And so what I'm basically careful here is to use the formula here that is useful for me. In this situation, computing g sub x cross g sub theta may not be the best plan of action. Why? Because I know the little outward normals for this type of the function, basically. And so what is that? That's basically for cylinders, for this type of surfaces, I know for cylinders, the little normal vector is just going to be for the free variable 0, and then the other ones are cosine theta and sine theta. Okay, so that's done. Then I have to just plug in f of g. Oh, and one more thing. I also know that the magnitude of n is going to be, for me, is going to be just Jacobian in this case. And because that's r, and r here is 2, so I just get 2. So it seems like this is the best method to use, this one, check mark. And let's go back to the formula. Let's find f of g. F of g is going to be for y, I have 2 cosine theta. So 0 2 cosine theta times z, which is 2 sine theta, and I get 4 cosine theta, sine theta, and z squared, I get 4 sine squared theta. Now dot these two together, and I'm dotting these two together, and I get, what do I get? I get 0 plus 4 cosine squared theta sine theta, and plus 4 sine cube theta. And so when I'm taking this integral, it's dot of these two and the scalar integral. And scalar surface integral is just that Jacobian n, magnitude of n, or magnitude of n is just g sub x cross g sub theta, magnitude of that, right? And so I get the 2 in here, and I get d theta, and I get dx. Theta was running, let's see, let's go back and figure out what theta was running. So over here, I know this point over here, if I plug in 0 for theta, and for whatever x I go, these are the points that I get. When I plug in pi, these are whatever x I get, these are the points that I get. And then points in between, basically, it's the positive side of the, for z, everything should be in the positive side. So theta is really running between 0 to pi. And then x is running between 0 and let's remember what it was. Oh, the upper bound was 1. Now we can compute. So let's compute, and here, let's see, let's clean up, then compute. This is 4 times factor the 4 out, and you get 8 out of here, 0 to 1, 0 to pi, and this factor is sine of theta, and something nice happens. Cosine squared theta plus sine squared theta happens, d theta dx, and then I will have 8, integral 0 to 1, integral from 0 to pi of sine theta d theta dx. Sine theta, that integral, and I can take that out of there, so I can have 8 times 0 to pi sine theta d theta 0 to 1 dx. This part is just going to be 1. This part is the negative cosine theta 0 to pi, which is exactly 2. And the entire thing is going to be 16.